Hello, viewers. In today's class, we are going to discuss yet another important and very conceptual problem from limits involving greatest integer function, right? So here, once again, we are going to solve one important problem which requires a lot of concept from greatest integer function to evaluate this limit, right? So let us start. Now here we have to find the value of this limit, right? So here we are given limit x tends to minus 1 and here we have the negative sign, right? So this negative sign shows that we have to find the left hand limit of this function when x approaches to minus 1 from the left of x is equal to minus 1, right? So here we are approaching from the left of x is equal to minus 1, right? Okay, and here we are given the function x times greatest integer of 1 over x raised to 100, right? Okay, so let us start, and here we have to find the left hand limit. So we'll write LHL, and we'll take here x is equal to minus 1 minus h, right? See, we have to find the left hand limit, so therefore we are very close to x is equal to minus 1, but with this point minus 1 minus h, it lies towards the left of x is equal to minus 1, right? So this point minus 1 minus h is very close to x is equal to minus 1, and here we have minus 1 minus h, right? And this quantity h is a positive quantity, right? And it lies between 0 and 1, and always remember that this quantity h is very small, and it is infinitesimally very small, right? So now when x tends to minus 1, then here h tends to 0, right? So now let us write this limit in terms of h, right? So what we will write here, limit h tends to 0, and for x we can write minus 1 minus h, and then here we have the greatest integer of 1 over minus 1 minus h and raised to power 100, right? Okay, now here if we closely look at this expression, we see that this is the product of two functions, right? So the first function is minus 1 minus h, and the second function is greatest integer of 1 over minus 1 minus h raised to 100, right? So we can now write limit h tends to 0 and minus 1 minus h, and then multiplied with limit h tends to 0, and we have 1 over minus 1 minus h raised to 100, right? Okay, so now here we have applied the result, that is the limit x tends to a, and if we have the product of two functions, then the limit it distributes over the two functions, right? So limit x tends to a f multiplied with limit x tends to a, and here we have the function g, right? So here f and g are both functions of x, right? Okay, so now here we can directly substitute h is equal to 0, right? Because this is a linear function, so here we can take h equal to 0. So here we have minus 1 minus 0, and here we cannot directly substitute h is equal to 0, right? And here comes the concept of greatest integer function, right? And it is going to be an interesting problem, how to evaluate the value of this limit, right? So here we have minus 1 minus h, and this expression here we take it as such. So we have here greatest integer of 1 over minus 1 minus h raised to 100, right? Okay, so now our next aim is to find the value of this limit, right? Because the value of this expression is simply minus 1, right? So what we will do, we'll take help of this inequality, right? So see, here we are given h lying between 0 and 1. So h lies between 0 and 1, and now multiply throughout by minus 1. So we'll have 0, and the direction of the inequality get reversed. So here we have minus h, here we have minus 1, right? And see, here we have obtained minus h, right? Now we can add throughout minus 1, right? So if we add throughout minus 1, we'll get 0 minus 1. Here we have minus 1 minus h, and here we have minus 1 minus 1, right? So this is minus 1, and here we have minus 1 minus h, and here we have minus 2, right? So now we can rewrite this inequality as minus 2 is less than minus 1 minus h, which is less than minus 1, right? So now we are having this important inequality, right? So now if we take the reciprocal throughout, because here we wish to find 1 over minus 1 minus h. So if we take the reciprocal, we'll get minus 1 over 2, and again the direction of the inequality get reversed. So we have 1 over minus 1 minus h, here we have minus 1 over 1, right? So again rewriting this inequality as minus 1 less than 1 over minus 1 minus h, and here we have minus half, right? So now we have arrived at a very important inequality, right? And see, this quantity 1 over minus 1 minus h, it lies between minus 1 and minus half, right? So see, here we have the number line, here we have minus 1, here we have 0, here we have 1, right? Now see, here we have minus 1, and minus half lies somewhere here between minus 1 and 0. So here we have minus half, right? And 1 over minus 1 minus h, it lies between these two numbers, right? So when 1 over minus 1 minus h lies between minus 1 and minus half, then obviously the greatest integer of 1 over minus 1 minus h should be equal to minus 1, right? So this is an important fact here, right? So when 1 over minus 1 minus h, it lies between minus 1 and minus half, right? So obviously the greatest integer of 1 over minus 1 minus h should be this number, that is minus 1, right? So now here we have minus 1 minus 0 is simply minus 1, and here we have 1 over minus 1 minus h, and the greatest integer is equal to minus 1. So we have limit h tends to 0, and here we have minus 1 raised to 100, right? So now we can omit this limit notation here, because here we do not have any h. So we have simply minus 1 raised to 100, and this is minus 1, and minus 1 raised to 100 is plus 1. So this is negative 1, right? So the left hand limit of this function when x approaches to minus 1 is equal to minus 1, right? So viewers, this is how we can solve these type of limits.